welcome to the spicy chain abstraction panel. We're going to have fun with this. So if anyone is familiar with the Hot Ones YouTube series where celebrities are interviewed with increasingly spicy hot wings, that is the premise of the format of this panel, where we will be eating increasingly spicy papaya salads. So over here is the least spicy, and we have 4 papaya salads. This is the most spicy.
And how do we determine which one we're supposed to eat? Are you going to rate our answers?
I'll give you cues and I'll eat the salads as well.
As the questions get spicier, so does the salad?
Yeah, I mean, knowing us, it's going to be as the questions get like increasingly complex, we're going to have to just start, sweating and trying to explain what's going on. Also, side note, I sometimes get hiccups when I eat spicy food. I really like spicy food, but there's a non-zero chance that I'm going to be moderating this panel with hiccups at the end. So sorry in advance. Okay, so represented on this panel, we have 3 very different approaches to private chain abstraction. And it's worth noting that none of these are live today, so we're going to have to kind of paint a picture of like what these systems are going to look like in the future. There's actually a lot of kind of prototype documents and like a series of conversations that we've had about like what these systems are going to be, and hopefully we can kind of describe them in enough detail so that you get a sense of what's going on. Chris just did a great presentation on the Anoma architecture, which has this resource-centric kind of security-aware bridge system. So Finch from Penumbra. Penumbra has a UTXO-based privacy pool, and the thought is that Penumbra will eventually be able to do remote actions via interchain accounts. And Dave, I don't think has spoken a whole lot about the Polaris system, so this is going to be some alpha, but is building an MPC-based custody system which has a kind of SGX layer that these validators can leverage. So yeah, I'm just going to ask each of you to kind of describe a little bit about the problem that you're trying to solve and some of the architectural choices that you made to get there. I'd like to start with, well, we'll go in order. So maybe we can start with Chris, I guess, since you just went. And while we're doing this, we can eat the first spicy papaya salad.
I can't
Chris
talk.
Chris can go
Oh,
last,
yeah.
I think.
So
So
first, okay.
we eat your talk.
Yeah.
Right. Okay.
Yeah, go for it.
Okay, so here I'm going to talk about a part of Anoma called the controllers system. And the controllers system, you can find an art published on this topic if you're interested, is our system for synchronizing state across heterogeneous trust domains and tracking the provenance graph of that state so that we can provide the kind of security isolation that we think users and applications want. That's a long paragraph. So let me break that down a little bit. So first, synchronizing state. So an Anoma state consists of resources. Resources are the dumbest state model in existence. You can create a resource once, and then you can consume it once, and then it's gone forever. But on top of this immutable resource system, you can build all of the complex abstractions. You could build on some kind of mutable state system like the EVM. What the resource model provides is 2 things. One, it provides a lot of clarity on like exactly what your state is and how it's changing at any given point in time. And 2, it's compatible with both maximum parallelism and maximum privacy or data protection, at least using zero-knowledge proofs at the state layer. So Anoma state consists of resources. And in our model, these resources are they live or are controlled by, and the controller terminology, are controlled by many different domains. And users might want to make trust assumptions about these different domains. So in the blockchain lingo of the world today, these domains are called chains. Now, why we use a different word, why we use the word controller and not chain, is 1, because blockchain is a data structure, but 2, to clarify the role distinction that we have in mind. Controllers they control whether the state can change, as in their signature or a block produced by the controller is required in order to allow a resource controlled by that controller to be consumed. However, controllers do not necessarily store the data associated with resources. That data might live elsewhere. It could sometimes be stored by controllers, but who stores the data is not a problem that you need to worry about for interoperability, for state interoperability, as long as you know how to verify it. So the controller system is designed to allow these resources to be synchronized, to be sent across different domains in a way which from the user's perspective is pretty automatic. Like you just think about what interaction you want to do on a particular domain and where you need to get the resources from, looking at where they are at the moment, and you can send them. But a way which also tracks what we call the provenance graph, tracks how resources moved across these domains, so that if a particular domain is Byzantine, then only users who consciously chose, or at least whose interface chose, to interact with that domain are affected, right? So if I'm a user and I don't accept a domain into my trust assumptions, whatever happens there, it's never going to affect me. This is the basic guarantee that a system like IBC strives to provide, and controller strives to provide that as well. The difference between controllers and IBC is that we've adapted it to the resource model. It's fully general, so capable of moving code as well as data, and it is compatible with privacy, as in the way we make proofs and demonstrate adherence to the rules which the controller system must enforce in order to provide these safety properties does not require the kind of sort of balance gateway checking that IBC does, where IBC keeps an account for each chain and makes sure the balance of that account cannot be decremented below 0. And this, at least not without fancy kinds of, I don't know, fully homomorphic encryption or something, this is not possible to make private. But the controller system instead provides its state provenance guarantees via a whole bunch of recursive zero-knowledge proofs, which is possible to make private.
Maybe just before we go to Finch, we can kind of stress this main trade-off that you're trying to negotiate between information disclosure about how many tokens have been bridged and the security. So this is really one of the core things that you're trying to solve, and you're kind of tuning the protocol on that basis.
Can I take a stab at trying to reflect back my understanding of what you're doing?
Yeah.
So you kind of imagine users have a bunch of resources that are kind of effectively UTXOs across a variety of domains. UTXOs are held privately. When they want to go do something, kind of the resource is routed across some network and consumed privately still. With all, and the key difficulty here is how you kind of declare what effective thing you want to do, what the effective thing you want to do, what the effective. How do you declare what the effective thing you want to do is without revealing too much of the action?
Right. Well, maybe it's useful to separate out two questions here, which at least to me are distinct. The first question is, how do you build an interoperability system which can preserve security isolation without requiring that all application data be disclosed? So IBC provides security isolation by requiring that you disclose the amounts and tokens of all of your transfers, because that's what's needed to keep the accounts. Controllers provide security isolation by verifying the particular state transitions involved and standardizing more, like it standardizes the resource model. That's question one. Then question two is maybe a more, call it a proof of stake style security question, which is what data do you want to be disclosed in order to make sure that nothing has gone quote unquote too wrong. So make sure that there aren't more assets on my chain than my proof of stake system can secure, or just see a little bit about the aggregate flows. And the controller's model does not make this decision. What it does is just not require that you disclose all the data. So you can still choose to disclose data as a user individually, and controllers who accept incoming resources can still choose to require the data be disclosed. But we're not making a sort of universal architectural requirement for any particular level of disclosure.
Okay, then what might happen is an app actually declares that, hey, if you want to use my trading app, you have to have this aggregate info. You should be willing to let the swap amount be aggregated with everyone else over 10 seconds for public.
Right. Exactly. Or you could, I think a very reasonable rule might be something like, every user must disclose some kind of, not their individual data, but some, additively homomorphic commitment to it, and then you add up a bunch of commitments, and periodically you decrypt the aggregate, and you get a sense of what the aggregate flows are in your system, and with some clever additional work, you can bound the change, the rate of change, like IBC rate limit sort of thing, but individual user privacy is not compromised.
You get to kind of generalize the turnstile system in Zcash.
Right.
Okay. I want to move on to Finch. Do you mind just describing a little bit about some of the goals of your system and the choices that you made?
Sure. So I'll just start with a real quick refresher on Penumbra for those who don't know about it. Penumbra is a shielded interchain DEX that's live today, and it connects over IBC to any IBC compatible chain. I think as of this morning, we had like 3.7 million USD shielded in the pool, so that's pretty cool. And we are exploring the possibility of doing shielded actions on other potentially transparent chains. So this approach is, I would say, maybe more evolutionary rather than revolutionary, as yours might be. We sort of assume the existence as it is today of public counterparties and build on the existing facility of IBC interchain accounts to say, what if we had interchain accounts that were compatible with the UTXO-based shielded model that powers Penumbra? How could we use this in order to achieve private actions on public counterparty chains using the existing trust infrastructure or trustless infrastructure of IBC? So a Penumbra-style interchain account, and I'll stress that this design is not specific to Penumbra, and it's not even specific to a chain that is private on the inside. It's just compatible with privacy. A Penumbra-style interchain account, or a privacy-compatible interchain account, looks like you establish communication with a counterparty chain over some relayer, over an IBC channel, and there's a protocol by which you can create an account, you can do some kind of transaction on that account, and there's a delicate set of sequence number tracking that makes sure that you don't have forks in the state as you're manipulating the account. So on the Penumbra side, or on any other shielded chains side, you can use this underlying primitive to get a sort of one-time use account on a transparent chain, which allows you to custody your assets within the Penumbra shielded pool and then perform actions outside the shielded pool while keeping your assets primarily within the sort of safe, shielded, long-term privacy custody context of Penumbra. So the vision is keep your assets here, interact with existing applications by using interchain accounts. Something like, oh, I want to do a trade on Osmosis, or I want to use some kind of lending protocol. I can create a one-time use interchain account, and because that one-time use interchain account is controlled by a shielded bearer NFT that's recorded in the Penumbra shielded pool, nobody can distinguish who owns that account. So the actions taken by it look like funds that are transferred out of the Penumbra shielded pool, done something with, and then transferred back in, and they're unlinkable to any other activity on the network. So that's the basic design.
Great. One of the things I really like about this design is you can imagine it as kind of like almost a wallet middleware, and it's like kind of vertically integrated into the wallet, and you just would interact with a normal transparent chain as if you were using that chain with a normal wallet. Dave? Yeah, do you want to give a little description of your project?
Yeah, so with Polaris, we're trying to make one UI that lets you trade kind of any asset across any chain. And so there's this problem where we want to let you connect your existing wallets, but then let's say you want to buy, I don't know, Algorand or something. You don't have an Algorand wallet. What do we do? And the goal is, okay, let's go make an account for you on your behalf with like MPC. But we also have this goal, we want to solve user privacy, right? And for your existing accounts and address infrastructure, we can't really do much. But once we have this opportunity to, where you as the user are willing to kind of delegate custody, it's still fully in your control. Well, but you're willing to add another MPC intermediary. We can have that intermediary keep your funds in a shielded pool. So then, you can keep your funds at rest when you don't want to store it in your existing wallet, in Nemata or in Penumbra, and then the MPC committee is only authorized to sign anything when your existing account infrastructure authorizes it. So now the privacy guarantee we can get in this world then is what is basically only you know your data, or the MPC committee has to collude and break an SGX, both of these, to reveal your data. So now, why go with this approach? And the bet is that people actually want privacy for things, but the key bottleneck is they have to onboard onto new wallets or new chains, and this is overhead. So now, if we, in the app layer, we should instead kind of make this not a problem. Let you use the app the exact same way, or even easier, if you have a in using privacy versus not, versus using your existing wallet. And this is how I expect the infrastructure to go for kind of any app where you have to onboard onto it. Like take Polymarket, if people have used it, you have to transfer funds onto it, make that transfer, transfer funds, put the funds into a shielded pool, and do everything you want there. Like it's the same style of approach that Finch was talking about, where you kind of have this public action, like your trade is public, but you don't know who's doing it. It's coming from a shielded pool as it originating and ending back in a shielded pool. So the claim is let's do that here as well, but like add in let the user be okay with an MPC committee collusion and SGX break together for de-anonymization.
Great. Yeah, you already kind of front run my next question, so maybe Dave, we can just kind of like loop it back to you. What are the main security trade-offs that you're making, and what did you gain by taking that trade-off?
Yeah, so the main security trade-off we're taking is if the MPC committee is broken and they break colludes and they break SGXs independently, they can one de-anonymize you and two steal funds. The stealing funds part, I think, should feel a bit less worrying, or should like remind you more of just bridging across chains, because it's actually, I don't know, using the word MPC maybe sounds scary, but if you like kind of stare and like think about it, bridging your funds to another rollup or another chain puts you at the risk of that chain's validator set, or for rollups, the multi-sig upgrade contract until they're stage 2. So the MPC committee is actually like a very similar assumption. You can have slashing conditions for if they do something wrong, and this looks actually a lot like standard proof of stake. So in my head, the big risk here is that okay, or the additional risk is they collude and violate privacy. And then the other part is there's actually just kind of a lot of hairiness for how to solve kind of metadata leakage things, and there the MPC committee can probably correlate your actions in real time. Like, hey, I want to go sign this transaction. I want to go do the swap. They're going to see that there was a swap request from some IP, and we produced a signature at the exact same time. This IP is probably this transaction, but they won't be able to know who the funds are. It's just correlating kind of the time of event and IP, which is actually what's going on as well, or it's kind of hard to beat, even when you're in the full privacy mode that you onboard into a new wallet, you're thinking just single chain context.
Great. Yeah, I'd like to invite Finch to do the same. Talk a little bit about your security trade-offs, what you gained.
So unlike the context that you're describing, Penumbra uses end-to-end encryption and ZK proofs to secure the long-term privacy and security of the funds on the chain. And so there are fewer, I guess, trust assumptions than in the system that you're describing. That's not necessarily a knock. It's just like there's like you establish things differently.
It's because you have lower security assumptions. We could actually use Penumbra or Nevada under the hood for how we get this.
I would love to talk more about that. Yeah. You incur the same kind of trust assumptions when you use interchain accounts as you do when you use any other sort of IBC, which is to say you're incurring Byzantine counterparty risk for any chain that you're transacting with. So if you establish an interchain account on some other chain and that chain's validators are Byzantine and they collude to do something nasty with your account, then your tokens or your other account state is potentially corrupted. But this doesn't necessarily compromise your privacy because your assets are still located within Penumbra and the interchain account is indistinguishable from any other interchain account. So a compromise of privacy on, say, some privacy-preserving counterparty chain doesn't bleed across to your privacy from within your home native environment.
Great. Chris, we should try to speed it up a little bit because we're only on Papaya Salad one.
Right, okay. I mean, I would say as a research project, Controllers basically tries to reach the security privacy trade-off frontier in interoperability systems, at least to the best of our ability. And for that, we definitely pay a lot of like protocol novelty cost and some amount of efficiency. Like there's some metadata tracking that we need to do for these resources that I hope will be cheap enough eventually, but we haven't built it yet, so we don't know. For us, I think that's the trade-off relative to these other systems. There is still, of course, long-term privacy can be secured using encryption and zero-knowledge proofs for resources, very similar to UTXOs in Penumbra. But there is still a kind of operational security privacy trade-off in how much data you require to be disclosed when you're moving state between domains. And this is not a decision made by the controller system, but it is a decision that users and controllers have to make, and what decisions they make determine where on the trade-off frontier you lie.
Great. Well, I'd like to invite you all to have the second papaya salad, and we're going to talk a little bit about UX. So when you're abstracting across heterogeneous environments, heterogeneous geographies, execution environments, validator setups, you just incur a lot of complexity cost, and you have to make decisions about whether to prioritize things like responsiveness, reliability, privacy. How are you thinking about UX in the context of this like very heterogeneous environment that you're in? Yeah.
Okay, wait, can you help me understand the question a little bit more? Are we talking about the happy path or like the path where like things are going wrong?
I mean, I think the things where they're going wrong, to be honest, like that, like
Okay.
you're gonna have to, yeah.
So okay, in the Polaris case, I think the things are going wrong situation is two parts. The underlying privacy layer is offline. Like in our case, Penumbra and Anoma is failing to produce blocks or failing to include transactions, or the MPC party is offline. The MPC committee is offline. So okay, for Penumbra and Anoma being offline, that's kind of equivalent to just you stored funds on a chain, and the chain is offline. It's not really anything you can do. Just funds are stuck until it comes back on. But now but I also think that's like kind of not that hard. Tendermint runs very reliably. So the more interesting thing is what do we do when the MPC committee is offline? And so the take there is the user actually creates the private key locally and then makes an encrypted copy to itself. And we're also trying to solve the problem where a user has many addresses. So let's say I have 5 addresses, and I want to go make a shielded vault. I'm going to go create a private key, encrypt it to each of my addresses, and post this encryption somewhere. Like, let's just say Osmosis blockchain for now. Oh, and then there's this reference of state that whenever I need, I could use my existing accounts and decrypt the private key to like recover access to the funds when if the MPC committee went offline. And even more so, a very complex problem with shielded things is how do you see your own balances? And because we kind of control the app interaction through Polaris, one of our goals is to create a spot of to let you see your own balance without having to resync the whole chain. Now, in Penumbra and Anama's case, what you do is the wallet maintains the state for you. And in the happy path, we can have the MPC committee have some encrypted state on your behalf. Like, I encrypt my own balance after every action and to myself, and they just kind of act as a storage spot for that. In the unhappy path where the committee is offline, then I can't access the storage. Then we have to go through this kind of unhappy path of, or our unhappy path is kind of the wallet sync protocol you have that you can see today in kind of Prax and Zcash, which is not that slow. I'm actually very pleasantly impressed of it's not tens of minutes, it's like a minute.
Do you mean the Prax wallet for Penumbra?
Yeah.
It'll get even faster very soon.
Oh, nice. And that's kind of the unhappy path flow we'll have. And really, I think the main bottleneck there is the engineering complexity of it. Even more, recovering the private key is not bad, but making the one UI also be able to back up do that sync logic is complex.
Finch, can I call on you?
Sure. So we were just talking about like the how do you recover funds, and I just wanted to speak to that to elaborate a little bit more. So the way that Penumbra thinks about client custody is a little bit different than a lot of other chains, and I think Anoma might have a similar model, but you'll have to tell me more. But when you are attempting to gather information about your own balance, Penumbra is a UTXO-based network. So you have to synchronize, as Dave said, you have to synchronize the entire history of the chain. But we've designed the underlying data structures, as pictured on this bottle, to be very, very fast. So you can skip ahead into the future by synchronizing only intermediate hashes in the commitment tree, and this allows you to get a full shielded sync of only your pi slice of the total shielded state of the chain very efficiently. There are a bunch of tricks that you can pull to make this even faster. So I was hinting at this, like there's work in the pipes to take that down from being a few minutes to instantaneous almost. So
the challenge is when you need to interact with chains outside of Penumbra, though. Now you need to plug into RPCs all over the place.
Yeah, and that is the trick, right? So if you're interacting outside of Penumbra, then you're using Prax Wallet potentially, which is the current native wallet for Penumbra. But if you had an interchain account system where you're needing to talk to other chains, then in the Penumbra model, you're interacting with other chains through interchain accounts. So you require the presence of relayers to relay those actions back and forth. And that potentially leads to a UX slowdown because of the necessity for the back and forth packet relaying. So that ends up looking like maybe tens of seconds to execute because of the IBC latency.
How do you imagine the UX of that looking? Like, is it that I go to an Osmosis.zone website and somehow we've hijacked balances to also include my Penumbra custody balances, and I can ask Prax Wallet to sign something and it does kind of this wrapping? Or
I actually love that question because one of the really cool things about Penumbra is that our client architecture is specifically designed to allow people to plug in third-party front ends that make use of the same wallet. So Prax Wallet is a browser extension, but you can build a website that just says, please access my Prax Wallet state. And from the perspective of the developer who's building the third-party site, Prax Wallet just presents almost like a traditional wallet that has an RPC to a public balance. So you can say, please compose a transaction to do this and such a thing, and request it of the user. So maybe Osmosis can integrate with Penumbra just by having a connect your Penumbra wallet button, and then the Osmosis front end can do what it will with that interface.
And there's representations within Penumbra of all remote balances. So if I have USDC actually like on Ethereum somewhere, there's a claim on that in a Penumbra that's being queried.
Yes, that's right. In the Penumbra interchain account design, the way that would work is you have the account established on the counterparty chain, but it's tracked as a shielded NFT that's a bearer NFT that controls that account. So when you have that in your wallet, you can perform actions that manipulate the remote account and generate those IBC transactions that execute things on the remote chain.
Cool. Chris, do you want to talk a little bit about Anoma UX?
Yeah, so I guess the central question in UX of controllers, at least the kind of top-level architectural one for me, is how to deal with and represent heterogeneity to the user, particularly heterogeneity of domains that cannot always be synchronized. So our state synchronization problem is kind of like if we had not one Penumbra, but infinity Penumbras, and we don't know which one
Beautiful future.
Right. We don't know which parts of which states the user needs to access at which time. So it's sort of, take all the hard problems in state synchronization, combine them into one. Anyway, we haven't solved all of those yet. I think there's the problem of like how to. There are two problems here.
Implementation detail.
Right. Implementation details, trademark. There are two problems here. There's the like protocol design side problem of how to actually get the right state to the user when all of the right parties are online at the right time without compromising on privacy. And what Penumbra does is to build a really super well designed and engineered client state synchronization protocol. And this, I think, will also be part of our design. Maybe we'll even reuse some of your excellent data structures. But at least for controllers and for the kind of heterogeneity of applications we're going with, I think we need to do more, because it's just not, I mean, when there are potentially infinity penumbras, it doesn't matter how fast your client-side state synchronization is, you can't sync all of them.
Right, you can't, like if you had, say, 1,000 chains, then you're bounded by network bandwidth more than you were bounded by client-side synchronization work or hashing or something.
Right. So parts of that problem that we've been investigating look a little bit more like your idea to have some kind of MPC committees or TEEs manage a little bit of the state synchronization on behalf of the user. But in our case, this is like we're trying to design some, I don't know, heterogeneous or sharded protocol by which the user can say, oh, there are at least 30 parties and they're going to handle different parts of my state synchronization, and I will shard the information between them by requiring that people who do interactions with me encrypt specific parts of state first to me and then to their specific keys.
So does that look sort of like onion routing among blockchains?
Yes, a little bit like that. With there's more of a computational element involved because you want sometimes conditionality for when state gets sent around.
Sure.
A little bit like that.
Yes, the mental model I have for this MPC stuff sounds like it'd be similar.
Papaya salad number 3 before we continue.
Okay.
Go ahead. sorry.
Wait, am I simultaneously eating and talking?
No.
Okay.
I'm in queue. So the mental model I have for this is that the MPC community is kind of like your own blockchain, or maybe in the Anoma words, fractal instance, because they have with their slashing conditions. But then Polaris, we're kind of optimizing around just get one working. Whereas I think in the Anoma land, you want users to be very explicit about who their custody set is. So you have a much harder problem of that, but it's also, I think, a good solution of, hey, I'm willing to give some timing information to one party, but they act as this like data store, this like kind of notepad. Where today you could always, something I think's not done in crypto today is you could kind of encrypt data to yourself on chain, but then you still leak kind of the access structure, which is also still very helpful for many things. But now we're going one step further of don't globally leak the access metadata, only leak to one committee.
Yeah, I also think if you have, you need to make some like one of n trust assumptions for privacy here, but you can just layer the onion routing, or so to speak. Like I can say, oh, as part of my transaction, you must, encrypt this blob that results from the transaction computation to this party, and they must send it to this other party, and they must send it to this other party who must send it to me. And yes, if all of those parties collude, you leak some timing information, but it seems to me like with reasonable configurations, and you pay some cost and bandwidth for doing this, but the user-facing privacy will be pretty good.
I wonder if something like, just taking the analogy of onion routing just one step further, I wonder if something like the way that NIM does homogenization of network traffic,
Right.
if that could be applied to this context as well.
That's a good question. Maybe. The problem is that the transaction timestamps are still discrete, and this is part of the timing information, right? Now you can delay. You can apply the NIM store, wait, randomize, and forward model, or whatever it is, to the actual data that's going around. But maybe the transactions can still be correlated. But if you don't know,
hit for sure. You take a latency hit for sure, which is maybe not what you want.
Well, but if the latency hit is on the order of a lot of this is happening when the user is not online. So you're adding delays, but they're delays that don't impact the user-facing latency.
Great.
And if the user is online, they can actually, they can probably just reconfigure the network to forward state to them more directly. So you could have some kind of split protocol.
Yeah, responsive. Cool. I just want to talk a little bit about go-to-market. Bringing, no one has successfully brought a privacy protocol to market, really. So a lot of challenges here. I think each of you has kind of unique challenges that you're gonna need to tackle. So Anoma, really, the composability architecture kind of presumes a world in which there's many Anoma applications. So maybe you want to just say a little bit about how to kind of bootstrap that minimum application set to really make it worthwhile. And you touched on this a little bit in your presentation.
Right. So there's this great meme, which is there are 13 competing non-interoperable standards, so I built a 14th standard. And Anoma is that meme. Except that when you are working with sort of distributed verifiable systems, the thing that you must standardize, the only thing you must standardize, and the only thing that Anoma does in fact standardize, is not how computation must be performed, but rather how it must be verified. So if you look at like the resource machine state architecture, the resource machine state architecture doesn't give one whit how solvers compute things, or even how like state changes are computed. It only cares about standardizing the minimum necessary to verify things amongst different users. And that, I think, permits us to do things like make Anoma intents interoperable with Ethereum intents, which really cuts the user-facing penalty for using some like different non-interoperable system. So strategically, that's our approach.
Finch, Dave, do you want to just comment on some of your main go-to-market challenges?
Sure. So one of Penumbra's main challenges is we've got this DEX. It's one of the most advanced DEXs that has ever existed. It has some really cool features like automatic in-consensus routing that gets you the best possible swap execution, and concentrated liquidity that allows you to shape your own payoff curves and mix passive and active liquidity. But all of these features need to be brought to people who are going to actually use them for there to be a bootstrapping of useful liquidity on the DEX. So one of the things that we're currently working on is encouraging 1,000 interfaces to bloom, because Penumbra is this really flexible protocol, and it has these atomic primitives that allow you to construct all sorts of different trading strategies on the private DEX. So why not give people a traditional order book interface that looks like trading on a centralized exchange? Why not give them an interface that looks like Osmosis? Why not give them an interface that looks like Uniswap v3 or v2 or something? You can, because Penumbra has this plurality of interface at the core design of the protocol, this means that the strategy for bringing more liquidity onto the DEX is to allow people to interact with the DEX as they most want to interact with it. So building developer experience and building user interfaces. Coming up very soon, there's as I said, a centralized exchange order book style interface that you can expect to see very soon. I'm quite excited to debut that to the world.
Wonderful. Dave, quickly?
Yeah, so with Polaris, kind of our insight on the privacy stuff is that we want to make this feel as hidden to the user as possible, like no wallet installs. Use whatever existing key material you have, your existing wallets. So the go-to-market for us is, have we made a good enough product for people with this UI that's like, have we nailed the UI interface for like giving portfolio viewing, getting you cross-chain trades, and whatever other feature sets you want in a UI? And then this privacy is kind of a feature that might be why you come as part of it, but what keeps you staying here is this UI is the app you want. And then the privacy part is now should feel like additional should feel like no additional overhead. It should be frictionless on top of the app, so then it's kind of focused. The go-to-market's on the overarching app, and the privacy is like this very exciting reason for what we're offering.
Mm-hmm. And I'd add on to that that I think in order for a privacy product to be successful, it needs to be successful not in spite of its privacy, but because of its privacy. So that's part of what we're trying to do, is to cause the user experience of using privacy to be successful precisely because you have privacy. And I wish that for you as well.
Yeah, thanks.
Okay, so we are now on the spiciest papaya salad we should go for. We only have a couple minutes left. I'm going to ask one more question. We just spent a whole bunch of time kind of elaborating what design decisions we've made, what trade-offs we've made. There's actually a lot of complementarity that's already been kind of surfaced in this discussion. Where do you think that there are kind of points of collaboration or like ways to create a more integrated experience that maybe cuts across a number of these different methodologies? Go for it, Chris.
Sure. So, I mean, to me at least, all of these approaches sound like they're trying to solve different and complementary problems, which all relate to the goal of giving users usable privacy in applications that make sense for them. Controllers, in order to kind of, at least our approach in research is to first define what we think are the key design requirements. And I'm also, personally, I worked on the IBC protocol before, and I just feel like I have some karmic debt from designing this non-private interoperability protocol, and I wanted to take that problem seriously. So controllers, first says, can we design a protocol, even in principle, that is compatible with this like crazy set of design requirements? And I think that we've actually accomplished that. But in order to get there, we've given ourselves an infinite budget for protocol complexity, an infinite budget for incompatibility, or at least not easy upgrades to existing systems, et cetera, et cetera. So now we need to kind of take this protocol and reason back to the existing systems and figure out what the next gradual steps might look like, both from the kind of protocol, but also the product perspective. And I mean, luckily, these are like two amazing next steps that people have already figured out. So I feel like we're coming at the same problem from opposite angles, and maybe eventually we'll meet in the happy middle, and then it's just a long road to, frictionless privacy that no one even assumes is a topic you need to discuss on panels anymore.
Guys, level 4 chili is spicy.
Yeah,
Chris,
this is getting heated.
It's quite powerful.
Any comments, Finch, on that?
Yeah, I think that's a pretty good analysis. I see Penumbra as trying to solve one problem extremely well, and to get that to market and into the hands of users. And then the ideal future vision of Penumbra is to grow into something that looks more generalized. So we've talked about things like dark asynchronous contracts, and things that sort of generalize the computation model in the context of a UTXO-based shielded pool. These interchain accounts, I think, act as a kind of incremental bridge between a private future and a transparent present. But eventually, as you say, if the future is private, if the future allows us to consent universally to where our data is revealed, then a design closer to what Anoma is working on might be the direction that Penumbra tends. I don't know. I'll be excited to find out.
Yeah, for me, I think the collab points are first, stuff can only exist thanks to the great work of Penumbra and Anoma getting shielded pools to exist on chains with a great bridging infrastructure. So then we need to get the UX around that nailed down. People who developed in Cosmos, RPC endpoints and broadcasts. These are things that take tackling. Now we have two new novel stacks. So you got to get this really streamlined. And so then we collab by using stuff and trying to get this improved. And then I think it's actually really exciting to me that Chris mentioned this as when you go to this heterogeneous world of people wanting to make their own security assumptions, you have to really streamline this MPC stuff even more. And that's kind of an exciting front of how do we do that without extra data leakage? And also, how do we make all this privacy stuff work from people's existing wallets? Because one thing that's happening in both these designs as well is kind of what forces us to use MPC even if we're willing to take infinite front-end complexity. We're forced to use MPC right now because there's no account abstraction framework in to my knowledge, that lets me do any of my arbitrary things. I want rate limits for the user. My phone passkey should not be able to drain my entire balance, only some amount. And so, how do we imagine getting the account abstraction framework, all the relevant data in there, and kind of for us, we're kind of throwing this off to an MPC committee. That's not the glorious long term. That's kind of how we get the user need done first. The glorious long term is on-chain guarantees, remove any intermediary.
And there's an interesting trade-off there. I used to have in a former life, I was a programming languages researcher before I was in blockchain. And there's an interesting trade-off to be found when you're trying to design general purpose expressive languages, where you either end up with something that's Turing complete, or you end up with something that's so restrictive that you aren't able to express all of the intents that you have. So that's the tricky thing in building a system like that.
Yeah.
So we have to wrap up. I'd like to thank everyone for humoring us with this crazy panel. I'd also really like to thank Radiant Commons, who provided the increasingly spicy papaya salads. Thank you so much.
Thanks.
Yeah, and thank you to Dave, Finch, and Chris.
Thank you.
Thanks everyone for listening.